All right, I'm going to take myself off mute here and get started. So let me put this in presentation mode. Okay. All right, so thanks everyone for joining the webinar today. This is titled Building IoT Apps in the Wild, Putting the Pieces Together to Build Successful IoT Products. So I am the solo presenter today, Brenna Hennessy, and I work at a company called Launchpad Lab. So just to give you a little bit of background about Launchpad, as well as myself. So Launchpad's a digital product studio, so we work with clients to build web and mobile applications for typically, new business ideas or new product ideas. And we'll actually cover one of the projects we did recently that kind of relates to IoT applications. So this is a picture of me, since I don't have my camera on. I wanted to make sure we had the slides full screen. So my name is Brenna Hennessy. I am one of the co-founders of Launchpad Lab. We're about 5 or 6 years old now. So I've been with us from the beginning, and my role currently is CTO. So I do a lot of technical management, but also still do a lot of development. And the project, again, that I'll be talking about, I specifically did some coding on, so had some experience with that. So I wanted to first start by kind of defining a couple things just to make sure that we're all sort of familiar with the terminology that I'll be using for today's talk. So this talk has IoT in the title. What does that stand for? That stands for Internet of Things. And the very dictionary specific definition is the interconnection via the internet of computing devices embedded in everyday objects, enabling them to send and receive data. And I added to be persisted in the cloud. So I think the main thing to think about when you're sort of framing what does IoT mean, because it can mean a ton of different things. Typically have some end user device that has sensors on it. And the picture I have here is of a Fitbit, which I think is probably relatively common to most people. So your Fitbit, this one that I have here measures your heart rate, measures your steps, and also measure your movement. All that data is collected at this end user device. But if it just sits there, it's kind of locked in that device. And you can kind of see there's really a pretty simple screen there. There's not a way to display any advanced data. So typically what you have is a app that this end user device will talk to, and that gets persisted to the cloud. And that's what allows you to view all this data in the website format. So another example of this comes from below is maybe more of an HVAC setup where you're measuring temperature controls and want to take certain actions. Being able to connect this device to the internet allows you to remotely control things and remotely monitor things. So that's typically the pattern you'll see that what I would say defines something as IoT. So when we think about IoT, it's kind of a larger ecosystem. There's a ton of things we could talk about. And the purpose of today's talk is probably more to keep it at a high level and keep it more introductory. There's many things that are involved in an IoT ecosystem. There's the hardware itself, the actual printed circuit boards, the actual sensors, how those work, how they're powered. At some level, that hardware needs to communicate, like I said, to a mobile app, and that needs to display certain information. And then that mobile app typically is connected to the internet and will persist the data in the cloud. And there's a whole visualization layer that can be added. There's many things that we can sort of discuss, and I'm going to pick a particular slice of that today and really focus on the mobile app experience and how should you think about designing and building that. The IoT sort of landscape and some of the constraints that you run into change the way that you think about building a solution or an IoT product. Myself, I come from more of a web development background, so a lot of the data is driven by user input. There's a form on a website and you collect that data. But in the scenario here for IoT, a lot of times the user isn't inputting any information. They're just kind of turning on this end user device and it'll start collecting data. So it's a little bit different way you have to think about displaying those results to the user because they might not even know that they were collected. So a lot of times, the main question that sort of comes out is this end device even working, right? If there's no real sense of it being on or how many steps it's counted, if it doesn't have any sort of display, there's this lingering question in the back of every user's mind: is this device working? And that's where we need to think about how our user experience and our design of the IoT product, and specifically the app, help communicate sort of what's going on with the system. So to sort of make sure that we're all have the same frame of mind, I want to define what UX is, and that stands for user experience, as well as, I guess, UI, which would be the user interface. So you can typically think about a web app, and that's sort of the top picture here, as something that displays data to a user on a device with a browser. So in this case, I think they're showing some market trends. And that data is populated maybe via an API or something like that. And we aren't too focused on what environment in which the user is consuming this information. Now, we do have the concept of a responsive design that'll scale down the display based upon the device you're on. We're not as concerned of in which environment the user is looking at this. If they happen to be at a Starbucks or at their home or at a library or even on the go on the train, other than the size of the device, we're not as concerned with where they are. And I think that's a pretty big differentiation between how you design for more of a pure web app and how you have to think about designing an app in an IoT landscape. So the example I'm harping on right now is this Fitbit concept of having a device that'll measure your, I guess, body signals during physical activity. So in this case, the user isn't tapping their device every time they want to track a step. The device is automatically tracking those. And what we want to be able to think through in the bottom use case is that some of the data that's being collected and the sensors that are reading them might not necessarily be behaving properly, potentially. So in the case of running on here, let's say there's perspiration sort of building up on the surface of your skin. Does that sort of mess up the sensor that's measuring your heart rate? And for all, I'll probably have the experience of steps being maybe double counted, which isn't so bad, but maybe not even counted. So there's all these sorts of things where the sensor or the device is really dependent upon the environment in which it's operating. If it happens to be very, very cold outside, maybe the sensor isn't working properly. It's not measuring things properly. So we need to think about how do we ensure the integrity of the data and how do we display that to users so they know what's going on. If they just see that their heart rate readings are way off, they're just going to be like, this thing doesn't work. So our user experience and our app has to account for more of these environmental constraints. So, why is this important outside of, just a webinar context or just an academic context? I think there's a lot of factors, but ultimately it comes down to time and budget. So the time to build something, the time to iterate, and then the cost to make it from a development side. So as a person producing the IoT product, how expensive is it to make it? How expensive is it to develop it? Coming from my perspective as a web developer, a lot of the things that we think about are how do we be agile? How do we be iterative? How do we build small and keep adding features, and then at the end of it, you end up with a very robust product that's understood by users, and you can see the progression of it over time. That mindset is definitely powerful, but it has its limitations in IoT, particularly around the fact that you have this hardware component. The iteration cycle on software itself is pretty fast, but when you have another interdependency on a piece of hardware that potentially might even need firmware update or a sensor needs to be swapped out. All these sorts of factors come into play that can change your ability to be All right, sorry about that. It looked like it lost our internet there for a second, so let me switch. Make sure my mic's on here. Okay. So let's see. And then back to full screen. So yeah, internet connection can be a problem, I guess, for these devices. But yeah, in general, I mean, you want to simulate the end user environment as much as possible. The more simulation you can do earlier on, you can sort of catch some of the problems that we might run into. And this concept of interdependencies is really important because you ideally want to run some of your efforts in parallel. So there's the actual hardware manufacturing, there's the software that goes on that hardware, and there's the software of the app that we're starting to focus on. And typically that's handled by multiple teams. So in that case, you're going to be coordinating amongst many different groups. And in that case, the cost of getting one of those things wrong or discovering an issue later on can be quite costly. So you want to try to stay ahead of that and sort of think about your product, think about your user experience from the get-go. So the example I want to run through that I think will illustrate a lot of these points is a project we recently, well, I guess we're recently launched, but continuing to work on called Breadcrumb. So this is a interesting use case. I'm personally not a hunter, but this is used by hunters for trackable technology for the outdoors. So there's actually two connected devices or IoT products here. One is something that goes on the back of an arrow. When you shoot it, it can track its location and it makes it easier to find that arrow. That's what's called a knock. Then there's also the location marker, which can be left behind at your hunting location, so it's easier to find. And that is particularly useful in a hunting scenario where you're coming to your location at usually a darker time of day, so either dusk or dawn, just depending upon the time of year. But usually it's a low light environment. Usually you're not hunting in the middle of the day, so it's important to be able to kind of like find your ideal location when you get back. So this provides sort of an interesting example of this environmental constraint kind of concept. How do we account for the environment in which these devices are being used? In this specific example, right, we have this, typically you're hunting in maybe a forest environment with variable temperature levels, variable humidity. Reception is, maybe questionable on your phone. It might be in sort of a remote location. So how do we sort of accommodate for those environment variables? Because they ultimately affect the performance of the overall system and the overall IoT product. So a quick primer on the architecture for this, which I don't want to dwell too much on. Each of these pictures could be its own talk, but kind of moving from the left to the right. On the left, you have the actual end user device. So this can either be the knock on the back of the arrow or the location marker itself. That device will communicate over Bluetooth to a iPhone or an Android phone that has an app on it. And that app can interact with the device, it can light it can trigger sound, as well as display signal strength that you're kind of seeing there. That information that is collected in the app is eventually persisted to the Salesforce platform, which uses Heroku and then Salesforce itself. But that is where the data is sort of persisted for later analysis. So the piece that we'll really be focusing on is that phone piece, kind of in the middle. There's three challenges that we encountered or had to address in the context of our build. So the first thing that we uncovered is how do we handle the idea of signal strength? So the concept that we have in this application is we want to be able to find these devices. So ideally, there would be this sense of, okay, here's the exact distance you're away from the device, and as you get closer, the distance drops, and that's kind of our UX. But in reality, that would be kind of thinking about this in too isolated of a context. The reason for this is because of interference. So as I mentioned before, these connected devices are using Bluetooth. Now, Bluetooth is a very common wireless technology that's used because it's low energy, so it's not consuming a ton of battery power, but it's also low bandwidth. And because it's low energy, it can't transmit a ton of data, and that transmission signal can be difficult to determine from the background noise. So that means if there's a tree in the way, that degrades the signal. Even though your Avid Pro flies relatively close to this device, how would you determine the exact distance if there's something that's interfering in the way? And those variables are very hard to account for, particularly in this use case of a forest that's going to have all sorts of trees and rocks and branches and whatnot that might be in the way. So there's kind of, when you think about the environment in which this is being used, it's important to then think about, okay, well, how do we sort of account for that? How do we give the user insight into what's going on, but not necessarily promise them too much or guarantee them that it's behaving a certain way? So there's kind of two main concepts there that we're trying to figure out the best way to communicate to the user: the magnitude or the signal strength, as well as the direction. And the magnitude is fairly easy to determine. The Bluetooth radio will tell you, okay, I'm at this signal strength, this decibel reading, which is great. But it's more of a radial kind of concept. You don't necessarily know which direction the signal is coming from. And that makes it difficult to develop a finding experience for that. So to kind of account for that, we borrowed or were inspired by maybe the concept of a metal finder, a metal detector on a beach. So when you are, on a beach looking for something, you have kind of the buzzing in your ears, and then as you get closer, as you're walking, as you're moving towards it, the beeping gets louder, the signal gets stronger. And we obviously don't use sound in our use case, but we kind of employed a similar concept where, because we're not 100% sure what the direction is, we do know that as you start moving, as you start walking and carrying this phone, we can measure the delta of the signal strength. So in that case, we can tell if you're getting closer or farther away by the movement that you have. So if you're just standing there stationary, it's difficult to tell. But as you move, you start to understand how the signal strength is increasing or decreasing. So the UI element that we use is kind of like the Wi-Fi signal kind of concept. So how strong is this? This is meant to sort of give that user a sense of, okay, am I getting closer? Am I getting warmer kind of concept? We can't necessarily guarantee a specific distance, but if you see these bars changing color to be bright, you kind of have the sense of getting closer. And because we can't necessarily guarantee the final location in terms of distance, the concept is really, let's use this finding experience on the left for, I'm 100 yards away, let's say, from the device. Then I'm going to get closer and closer and closer, and then maybe I'm within 10 yards, let's say, of the device. It's still tricky, right, to find this. That's where we sort of enable this light or light and sound combination. So we have a LED light that's on the actual device itself, and this app allows you to illuminate that or turn on the sound. And that's kind of the final finding experience where, oh, I can see the light right over there, and I can walk towards it. You're not necessarily using your phone. So all these sort of things, the way in which we had to design and think about the user experience really evolved because of the environmental constraints that we were under for the specific IoT product. And this happens to be because the signal strength reading isn't something that a user reports. It's something that a device reports. So we have to understand the environment in which the device is operating. Otherwise, we might assume we'll get a certain quality of data or a certain accuracy that we can't necessarily guarantee in the app. So this is a good kind of example of like, okay, we can't just think about, oh, I have this signal strength being reported. Let's just display it in this very pretty sort of graphical animation. We have to think about, well, how is that data actually going to be given to us? How are we going to get those signal strength readings? And in a way, we had to simplify the design to a certain extent because we couldn't necessarily guarantee results, the more exact distance measurement. So the next constraint is power. And this is probably the #1 problem in IoT is how do you power the device? And there's lots of different battery technologies that are improving, but at some level, if your device isn't connected to the network grid, there's some sort of battery that's powering it. Maybe you have solar panels, but those have their own constraints. So So you have this concept of the device will have a certain amount of charge, a certain amount of power that it starts with, but it's going to degrade over time, either through just that device being out in the wilderness, in our case, or it just being used, right? It's going to consume power over time. And what you start to see is over time, when that power reduces, you'll just see reduced performance. Maybe you're not getting as frequent of readings from the device on where it's located, or maybe you're having inconsistency with how bright the light is illuminating. So you start to see that change over time. And ultimately, we need our app sort of explain to the user what's going on, because it might be frustrating if all of a sudden things don't seem to be working. We need to articulate to the user, like, here's something you might want to investigate. This also is kind of an interesting segue into a larger topic that I'll just touch on, is the idea of customer service for these different devices. So in the context of our use case, let's say the batteries go out and we're using a special type of battery. If the user has to figure out what battery they need to get, that can be pretty frustrating to know which one to order. But if our device can measure the battery level and then report out on it, that can provide a very powerful way for a customer service touch point. So in our application, we currently have this concept of battery level, which going into this project would have never thought would have been as important as it is. But you can see that we're monitoring the battery status. And when the device is working, most people don't really care what the battery level is. But by measuring it, we can determine when, okay, it's at 50% capacity, we might want to trigger a customer service workflow that'll send this user an email and say, hey, it looks like your batteries start running low. Maybe you want to pre-order or order some replacement batteries to make sure that at some point when the batteries do run out, they have those replacements ready to go. It's a pretty powerful concept that, again, like battery usage is something that's maybe not as strongly considered in a web development environment. You sort of assume, well, if they have their browser running, that they have power to view this. But when you have the end user device, depending upon its own batteries, you need a way for the app to measure that and communicate the status to the user. Okay, the last one I want to touch on is the ability to provide updates. So for a typical App Store release, you can download new versions of your actual phone app all the time. But the process is slightly different for the actual hardware itself. So in our case, let's say we have our location marker and the pinging of the Bluetooth signal is kind of wearing the battery down or something like that. In that use case, that frequency of pinging for the Bluetooth signal might not be controlled by our application. So in reality, there might need to be a firmware update. And the firmware is the small amount of software that's actually running on the hardware device itself. So a lot of times you'll find a need to, once you ship the IoT product out, you need a way to sort of remotely update. So sometimes you'll get this referred to as over-the-air updates. And those can be for security reasons or performance reasons, as I kind of mentioned. So in our use case, the typical sort of pattern you'll see from a UX perspective, kind of showing our mock-up on the right, is that you want to provide a way for the actual mobile app itself to install or upload a new firmware version to the end user device. And what that allows you to do is remotely update these devices. You don't necessarily have to have someone return the location marker to the factory to have it be reinstalled or something like that. So it's pretty important to accommodate that user experience and develop a UI around how do we sort of remotely update. And the example that I always like as a Star Wars fanboy is the BB-8 toy that I think came out a couple years ago. But I took or found a picture of this where you're updating the firmware that's actually in the little toy itself, and the phone is displaying the installation percentage, which happens to be 99. And then the device itself is actually illuminated, meaning that it's receiving a software update. So it's funny because I think for this one, there actually was a security flaw that would allow someone else to control your robot, which maybe isn't too big of a deal. But so they actually provided a patch for that, and they were able to use the mobile app to install that on the device versus some sort of customer service workflow that will require you to return the device and get a new one, and kind of hopefully avoiding any of those like logistical kind of challenges that you might run into. So that's the last example that I had, and I think that I thought about listing out more challenges, and if I listed out 4, what's the 5th one going to be? And if I listed 5, what would the 6th one be? And I think it's important, the theme that I saw sort of running true through all of these is thinking about the system a little bit more globally. So when we think about the mobile app, when we think about the web app in an IoT product context, the app is really the communication vehicle from the low-level device to the end user. And it plays out in a number of ways, right? We talked about signal strength, we talked about power, we talked about being able to update the device itself. But many times you'll see the IoT end user device itself it's trying to be very efficient. It's trying to be very effective. Like, we want to replace the battery as little as possible. We want this thing to last as long as possible. So in that case, the less that device has to do, the better. That's going to be the easiest thing to engineer for and build for. The challenge with that, though, is that the more stripped down the end user device becomes itself, the more maybe confusing or mysterious it can be for the actual consumer that's using that information. And that's why the app becomes such a key part of the overall system, because that's the way in which the user knows what's going on with this device. There's ways with sound and light to communicate things, but there's only basic things that can communicate. If you want to communicate a battery level or a signal strength, you're going to need a little bit more complicated UI. And the phone provides a very great interface to do that. But if you think about the phone too much in isolation and not understanding how that end user device is going to be interacting, you might be able to assume you can get too much information out of the device that you might not be able to guarantee. So it's important to think about how that end user device is operating and what environment it's operating in, because so many of those factors can affect the quality of the data and the amount of data you can get, and ultimately it's going to affect the user experience. So it's a much easier scenario to solve for if you can explain to the user what's going on. Oh, we're seeing reduced signals due to low battery. Oh, you replace the batteries, versus the feeling that this app just isn't working, this device just isn't working. And that's why thinking about this app as that communication vehicle usually is a very powerful paradigm that will allow you to sort of catch a lot of these gotchas earlier in the process, that what would ultimately hopefully save you time and budget that's been allocated to actually build the hardware and build the software. Okay, so that ends like the formal part of my talk. I know we scheduled this for an hour, but I wanted to leave some time for Q&A. I know this is over at the lunch hour if you're on Central Time Zone. So I want to open it up for questions here and see what all you have. So let me do that. And I'm going to unmute us all. Okay, everyone should be able to ask a question if they have one. Okay, if we don't have any questions, I think the last thing, I'll leave some parting thoughts. So, when I thought about doing this talk, there's a lot of different ways it can go, right? And I think the, follow-up webinar for this could be one, a very data-centric focus. So once we get the data out of the device, what do we do with it? How do we visualize? How do we understand those customer service workflows that we might be accounting for? So I think that would definitely be like a whole other topic. I think another area that's particularly of interest is kind of more of a technical deep dive into how the device is communicating to the app and communicating to the phone. I mentioned, in this specific use case that we have, using Bluetooth. That's not the only technology that you can use to communicate. There's radio, there's Wi-Fi, there's cell, and all of those things, provide upside in the context of, potentially higher bandwidth. You can send more data around, but they also typically use more power, more energy. So if something has the ability to connect over Wi-Fi, that requires more power to operate that device as opposed to Bluetooth. Just potentially a deeper dive into that sort of topic that touches on the actual communication protocols and technologies that can be used. But this one's a little bit more high level, a little bit more introductory to products and kind of UX design to account for in an IoT landscape. Okay, so I will end the webinar now. I've been recording this. I know it dropped out there in the middle, but hopefully we got all of this recorded, and then we will follow up with this recording, and I will hopefully get you guys a view-only or read-only version of the slides, just so you have it for reference. So thanks everyone for attending. I hope you enjoyed it, and if you signed up for this one, we'll try to follow up when the next webinar is available.